completers. I saw some of the notebook is very wonderful. Okay, keep on going like this, guys. And one more thing, make sure you are submitting the class works as well as your test note within this week. Okay, you are not submitting the class works. Okay, and tell me the marks. What are the marks you have got from the August and September and October monthly tests? Okay, before I have to, I need to enter on the system. And get the record notebook from the office room and make sure the last, write all the experiments. Okay, write all the experiments in your textbooks they given. Okay, we have the 10 experiments. Write all the experiments enough. Okay, don't waste your leave days and don't waste your time. Write everything. Next one thing, we are dealing these lessons electromagnetic waves. We know that, okay, what are the sources of electromagnetic waves and then accelerator charges. Okay, and who predicted this one? James Clerk Maxwell. After that, who proved this one? Henry Hertz. So to honor that Henry Hertz only, we are using that SI unit for frequency Hertz. Okay, so now after that we learned what is the displacement current and what are the sources of electromagnetic waves, and then what are the properties of electromagnetic waves. Electromagnetic waves are non-mechanical waves. It's in the transverse in nature. It's accelerated by any charge. Okay, electromagnetic waves are produced by accelerated charges. Okay, and one more thing is consists of the magnetic energy as well as electrical energy. Okay, the next one thing is very important one thing, that is called electromagnetic spectrum. Okay, electromagnetic spectrum. What is meant by spectrum? Spectrums consist of all the colors. Okay, you know that when the white light passes through that prism or something, white color passes through something crystals, it's dispersion of 7 colors with GR, right? Same like that in the spectrum, electromagnetic wave spectrum. We have the 3 rays and then waves. After that, one visible light. Okay, so we'll go for this one, electromagnetic spectrum. Electric and magnetic spectrum, both are the electromagnetic waves. What are the waves? So keep on remember this. We have the 7 types of electromagnetic spectrum. First one, radio waves. Okay, it is called radio waves. Remember all those things by Roy, married Indian, visitor USA, experience good. Okay, radio wave, microwave, infrared, visible, ultraviolet, X-ray, gamma ray. Roy, radio wave, married, microwave, Indian, infrared, visitor, visible light, ultraviolet, USA. Okay, ultraviolet, experience, X-ray, good, gamma ray. Okay, so remember like that. Okay, Roy, married Indian, visited USA, experience good. First one, the radio waves. What is meant by the radio waves? The radio waves are produced by accelerated motion of charges in conducting wires. When the wires, okay, we have the accelerated charge motion of the charges in the conducting wires. They are producing the radio waves. Okay, so what is the frequency ranges of these radio waves? Is up to 10 power 9 hertz, and then few ranges. Okay, it's few hertz to up to 10 power 9 hertz. We can make the radio waves. Okay, it obeys reflection, diffraction. Okay, reflection and diffraction only it obeys. After that, what are the uses of radio waves? The radio waves are used in the cellular phones to transmit the voice communication in ultra high frequency band, and also it's used in the radio and television communication system. Radio and television communication systems. Okay, the second one we call microwaves. What is that microwaves? It's produced by the vacuum tubes. Okay, such as klystron, magnetron, and gun diode. Okay, gun diode. So microwaves are produced by the special vacuum tubes. The frequencies ranges from 10 power 9 hertz to 10 power 11 hertz. 10 power 9 to 10 power 11 hertz. It also obeys reflection, polarization, and what are the uses of these microwaves? To find the speed of the vehicle, and then also is used to aircraft navigations, and also is used to very long distance wireless communication through satellite. Very long distance wireless communication through satellite. Satellite also we are using this kind of microwaves. Okay, so the next one is called infrared radiation. Infrared radiations, that is nothing but produced by hot bodies. It's also known as the heat waves. Okay, it's also known as heat waves. Then also when the molecules undergoing the rotational and vibrational transition, these waves will be produced as. Okay, so what is the frequencies ranges? Is 10 power 11 hertz to 4 into 10 power 14 hertz. It's also provide the electrical energy in the solar cells for the satellite. Okay, when the satellite revolve around the earth, it needs some energy, right? So during that satellite revolution, the solar cells are placed in front of the satellite that makes sure that gains the energy from the satellite. Okay, solar cells. What is the solar cells? Nothing but it converts the light energy into electrical energy. Okay, it's also used in the heat therapy for the muscular pain and also heat physiotherapy. Okay, they may be infrared. They are using the red color lamp, right, to find the muscles pains or something in the nervous systems. Okay, and the night vision photography. Okay, in the all CCTV camera, you may see the lot of CCTV camera with red color dotted lights is there, right, to night vision cameras, and infrared photography, infrared to long distance photography, infrared for the mist, and we have the fog during the winter seasons or rainy season to find the weather report. To find the weather report, we have to use the meteorological department will use that infrared to make sure that take the photos from the satellite. Okay, the next one is visible light. So the visible light is nothing but produced by incandescent bodies and also radiated by excited atoms in gases. Excited atoms in the gases. The frequency ranges from 4 into 10 power 14 hertz to 8 into 10 power 14 hertz. 4 into 10 power 14 hertz to 8 into 10 power 14 hertz. The reflections also obeys reflection, refraction, interference, and diffraction, polarization. All the things the visible light can obey. And also it exhibits the photoelectric effects also. It exhibits photoelectric effects, which is one of the famous scientists found with the Einstein. Photoelectric effects also will be obeyed. And also it can be used to study the structure of the molecules, arrangement of electron in the external cell of the atom, arrangement of electrons in the external cells of the atom. And it also causes for the sensation of vision. Sensation of vision. So without visible light we cannot see anything. Without visible light we cannot see anything. Okay, that's why we are using this kind of visible light. Okay, we also use it to study the structures of external cells. Okay, electrons in the external cells of the atom. And the third one, the ultraviolet radiation. Ultraviolet radiation. In ultraviolet, how is produced? It can produce by that sun, arc, or ionized gases. Okay, the frequency ranges 8 into 10 power 14 hertz to 10 power 17 hertz. 8 into 10 power 14 to 10 power 17 hertz. Okay, and also it has a less penetrating power when compared with X-ray and gamma ray. Ultraviolet UV rays having the less penetrating power. Okay, it can be absorbed by the atmospheric ozone and is harmful to the human body. Okay, when it enters into the human body, it can produce more amount of heat energy. That's why it has a less penetrating power. And also remember that by ozone, it's absorbed by the ozone layer. That's why it's not affected to the harmful. Okay, it's not harmful to our body. It is used to destroy the bacteria and also using the sterilizing the surgical instrument. Okay, when the doctors are the operations, after the operations they are to sterilizing all the instruments. Okay, surgical instruments by UV rays only. Okay, ultraviolet rays. And also theft alarm is used in the theft alarm, and also detect that invisible writing or invisible sign. Okay, not sign, it's invisible writing. Okay, for example, the forged documents. Okay, we have to see in the forged documents, maybe CAD or CBA something, they are using that ultraviolet ray to find that invisible writing and invisible signs, forged documents. Okay, using the forged documents. And also fingerprints, and also study of the atomic structure. Study of the atomic structure. The next one things is called X-ray. How the X-rays are produced? It was one of the discovery happens in the accident only. The Röntgen, you know, Röntgen. The William Röntgen discovered this X-rays when the fast-moving electron strike the target of the high atomic power masses, then they produces X-ray. Okay, it's produced when there is a sudden stopping of high-speed electron at high atomic number target. Also by electronic transition among the innermost orbit of the atom. The frequencies ranges from 10 power 17 hertz to 10 power 19 hertz. 10 power 17 to 10 power 19 hertz. Okay, when compared with the ultraviolet, they have the more penetrating power. X-rays are having the more penetrating power than ultraviolet radiation. X-rays are used to extensively studying the structures of inner atomic electrons. Okay, UV rays and then what is that? Visible light can study the structure of external cell of electrons in the external cell of the atom. This one you use to study the inner cell of the electrons. Okay, inner cell of the inner atomic electron cells and crystal structures. Okay, it is also used to detect the fractures, diseased organs, and then to detect the formation of bones and stones in the formation of bones and stones, and also observing the progress of the healing bones. Further, it is in the finished metals, fine metals. After that finished metal product, it is used to detect the fault, cracks and holes in the metals. Okay, and the last but not least is called gamma ray. What is a gamma ray? Okay, how is it produced? It is produced by transition of radioactive nuclei. It's produced by transition of radioactive nuclei and decay of certain elementary particle. Okay, when the uranium U38 or U35 above that 192, okay, which is the atomic number greater than the 182 and greater than the 82, they produce automatically, naturally they produce alpha, beta, gamma rays. Okay. So gamma rays high penetrating power. This also produce fluorescence and then ionization, and also they strike the photographic plates. Okay, the frequency ranges will be 10 power 18 hertz and above. 10 power 18 hertz and above. Gamma rays have the high penetrating power than X-rays and ultraviolet. X-rays and ultraviolet. Gamma rays have the more penetrating power. Okay, it has no charge. It has no charges. Gamma rays, the neutral charges, they never deflected by electric and magnetic field. Okay. So what happened? But it is no charge, but it is very, very, very harmful to our human body. Gamma rays provides the information about the structure of atomic nuclei because it is no charge, so we can enter into the atomic nuclei itself. It is used to radiotherapy for the treatment of cancer and tumors in the food industry to kill the pathogenic microorganism. Okay, radiotherapy, the cancer treatment also we are using this kind of gamma rays, but the gamma rays affected our body, it definitely give the blood cancers and also skin cancers, something like that. Okay, and then what is the types of spectrum and absorption spectrum for lights? Okay, when the object burns, it emits radiation that emits the electromagnetic radiation, which depends upon the temperature. If the object becomes hot, it glows in the red color. If the temperature after further increase, it glows in the reddish orange color and becomes white when it is hottest. Okay, so remember that when the object is burned, initially when the high temperature initially it's shown red color. When you heating more or when the temperature is increasing more and more, then it will become reddish with the orange color. While you are increasing more amount of temperature, then it will become white in color. Okay, or it is in the white in color. So suppose we allow the beam of light, white light pass through the prism. What will happen if I have the prism like that? Okay, if I have the prism like that, if I am sending the white light through the prism, what will happen? If I am sending the white light, maybe the refractor. Okay, so maybe the red color, UGR, and then the violet color. So UGR color will be observed. Now listen. So violet, indigo, blue, green, yellow, orange, and red. So 7 colors are obtained. This is the white light, which is consist of all those 7 colors, is called spectrum. It is called spectrum. Okay. The prism, it is split into the 7 constituent color which can be viewed on the screen is continuous spectrum. The phenomenon known as dispersion of light. Okay, this one we known as dispersion of light. And the definite pattern of colors obtained on the screen after the dispersion is called spectrum. Definite colors are obtained on the screens. It is called spectrum. The spectra can be broadly classified into 2 categories. First one is called absorption spectrum. The second one is called emission spectrum. Okay, so spectrum. Spectrum. There are 2 types of spectra. One is called emission spectra. The other one is called absorption spectra. Okay, so absorption spectra is nothing but, emission spectra is nothing but when the spectrum of self-luminous is taken, it's get emission spectrum. Each source has its own characters of emission spectrum. Okay, so this continuous. What will happen? The self-indulgence. When you have the light, it illuminates some monochromatic light. That light we called as emission spectra. Okay, we have the three categories in this emission spectra. First one is called continuous emission spectra. The second one we call continuous emission spectra. The second one we call line emission spectrum. The third one we call band emission spectra. Okay, band emission spectra. What is a continuous emission spectra? If the light from the incandescent lamp, okay, maybe you know that yellow color lamp, right? So filament bulb is allowed to pass through the prism. Okay, when you have the incandescent bulb which have the filament inside, when that light passes through the prism. When light passes through the prism, it's split up into the 7 colors. It consists of the wavelength containing all the visible colors ranging from the violet to red. Violet to red. The incandescent bulb which is produced by heat only. Okay, so when the more amount of heat given to the filament, then produces the hottest wave. This is nothing but your white in color. Okay, so when the white light passes through the prism, it gives the 7 colors, which is called continuous emission spectra. Okay, example, spectrum obtained from the carbon arc or incandescent solid. Carbon arc or incandescent solids. Okay, from this we can get this spectrum. We can gain this spectrum. Line emission spectrum. What is the line emission spectrum? The light, suppose the light from the hot gas. Okay, light from the hot gas is allowed to pass through the prism. Is allowed to pass through the prism. The spectrum is observed. This line spectra is also known as discontinuous spectra. Line spectrum is also known as discontinuous spectra. What will happen if you throw that? It may be like this. Okay. Line spectrum is also known as discontinuous spectra. The line spectra consists of the sharp lines of the definite wavelength or frequencies. Sharp wavelength and definite frequencies, they have the line spectra. Such spectra arise due to the excited atoms of the element. Excited atoms of element. Okay, this is also important. Excited atoms of elements. Excited atoms. Remember that, excited atoms. Okay, when the atoms is excited, when they fall back, they given the kind of line spectrum. And also, for example, spectra of atomic hydrogen or helium. Spectra of hydrogen, atomic. Okay, spectra of atomic hydrogen and helium. Okay, this kind of they given the line spectra. Band spectra, band emission spectra. Okay, band emission spectra or band spectrum. Band spectrums consist of several number of very close phased spectral lines which overlap together, forming the specific bands which are separated by the dark space. Okay, so this spectra will be obtained like this. So here we have the colors in the line. Okay, only the narrow point. Here we will get the lines like that. We get the colors like that in the band of spectra. Okay, the sharp edges are the one end, the fats out of the other end. Such spectra arise due to the when the molecules are excited. When the molecules are excited. When the molecules are excited, then they can produce that band spectra. Then can produce as band spectra. The characteristics of the elements are different for the different elements. Okay, the band spectra, these lines, and also structures molecules can be studied using the band spectra. Spectra of ammonia gas are in the discharge tube. Okay, spectra of this one is for hydrogen atom, this one for ammonia. Okay, in the discharge tube. Okay, so emission spectra, when the direct source, when the spectrum of the self-luminous source is taken, that is called emission spectra. There are 3 types: continuous, line, band. So what is the continuous spectrum? When the light source from the incandescent bulb, it is nothing else. The incandescent bulb is nothing but the filament bulb, which is produced the white light, passes through the prism. It consists of 7 colors. As it obtained the screen, 7 colors we can obtain. So these are the examples for continuous spectra. The line spectra from the hot gas, hot molecules can produce by the line spectra. Can produce the line spectra. This one, the excited consists of several number of very close spaced spectral lines overlap together. Okay, so this one fell to one side and then dark at another side. Okay, the molecules, when the molecules are excited, this kind of band spectrum will be produced as absorption spectra. Absorption spectra, when the light is allowed to pass through some medium, after that is the spectrum is obtained. When the light is allowed to pass through the medium or absorbing the substance, and the spectrum is obtained known as absorption spectrum. Except now if I have the blue color, except the blue color, all the color will be emitted. Okay, so that material or medium absorbing the blue color, after that it emitting all the colors except that blue, then it is called absorption spectrum. Okay, here also we have the three types. The first one is called continuous absorption spectrum. Continuous absorption spectrum. What is mean by continuous? When we pass the white light through the blue glass plate, when we pass the white light with the blue glass plate, what will happen? Okay, it gives the, except the blue, it gives the continuous absorption spectrum. Except the blue, it gives all other colors. That is called continuous absorption spectrum. The second one is called line absorption spectrum. When the light from the incandescent lamp passes through the cold glass. Okay, white light, when it's passing through the cold gas, which is have the low temperature gas, okay, medium, the spectrum is obtained through the dispersion. Okay, spectrum is obtained through the dispersion. Is it is called absorption spectrum, line absorption spectrum. If the light from the carbon arc made to pass through the sodium vapor, then it is continuous spectrum. The continuous spectrum of the carbon arc with two dark lines with the yellow region is obtained. Okay, the third one is called band absorption spectrum. When the white light passes through the iodine vapor, that means crystal is solids. Okay, when the white light passes through the iodine vapor, the dark bands on the continuous bright background is obtained. This type of band is also obtained when the white light passes through the diluted solution like the chlorophyll or blood. Okay, so diluted solution, blood or chlorophyll, or through certain solution of organic and inorganic components. Okay, so these are the two types of spectra. One is the called emission spectra, the other one is called absorption spectra. And also we have the Fraunhofer lines. What is the Fraunhofer line? The spectrum is obtained from the sun. Okay, when you are looking at the sun, there is a continuously looking at the sun, they may give the dark circle in the center, right? So how it's possible? The Fraunhofer lines. Listen first. The inner core of the sun. Okay, the sun have the two cores, outer core and inner core. Inner core of the sun have the more amount of temperature because what is happening? It is called chromosphere, right? It is called chromosphere and photosphere, right? Chromosphere have the 14 into 10 6 into 10 power 14 Kelvin. That much of temperature, which is on inner side of the core. Outer side we have that only into 10 power 6 Kelvin. So when hot temperature, when the high temperature producing that waves is continuous spectrum, they given the continuous spectrum. But when you enter into the cooling phase, when compared to this inner core, the outer photosphere having the lesser temperature, so it is act as a cold place. So when you enter into this, gives the dark band lines. Okay, dark line spectrum or dark band spectrums will be obtained. So when the spectrum is obtained from the sun is examined, it consists of large number of dark lines. Because it's observed and then only it can emit the dark lines. Okay, so the dark, what will happen if I'm observing all the sunlight? What is backside of mine? Okay, this is shadow, right? So like that, when the hot temperature on the hot inner core of the sun producing the continuous emission spectrum, after it is observed by the outer layer photosphere, and then it can only use the dark lines. Okay, so when the spectrum obtained from the sun is examined, it consists of large number of dark lines, that is line absorption spectrum. These dark lines in the solar spectrums are known as Fraunhofer lines. It is called Fraunhofer lines. Okay, Fraunhofer lines. The absorption spectra for the various metals of the compared with the Fraunhofer lines in the solar spectrum with the help of the identifying the element present in the sun's atmosphere. Okay, so alhamdulillah, we are completing this lesson with this Fraunhofer lines. Okay, hope you are understanding these lessons, and then inshallah you can. Okay, so I will make you to read, and I will give the continuous test to prepare for your examinations and continuous. What is that? We'll have the testers and keep regularly. Okay, so don't worry about this, guys. Again, I'm telling this one. Please submit your class works as well as test note within this week. Okay, Allah Hafiz.